All right. Hello. Thank you, everyone, for being at our presentation about the A&E forecasting tool that we're working on. I'm Yao Yao, and this is Jane. This presentation will give everyone introduction to the tool that we're working on and move on to talk a little bit more about the development and the improvements that we've been making.
We got someone who can move the slides on?
Oh, I did it. Okay. So we're on the central data science team at NHS England, where we work on a variety of projects involving predictive analytics, reproducible analytical pipelines, AI, machine learning, and so on. So yeah, we'll first be going into the background about the motivation, outputs, and what kind of model that we're working with, some of the development that we've been doing recently, and some improvements of the model that may or may not have worked. So for a bit of background, people admitted to hospital through emergency departments are unplanned admissions. So providing intelligence on this helps planning resource allocation, staffing, and beds. The tool is a daily 3-week look-ahead forecast at trust level with site breakdowns, and it uses the emergency care dataset. So this is an example of one of the forecasts for the Blackpool Teaching Hospitals Trust. And this dashboard exists on the federated data platform. So the way it works is we have the historical fit of the data in the blue line and areas there, and then in the purple, red, it shows the predicted forecast. The dashed line shows the expected value, and the blue solid line is expected value for the historical fit. It also shows the specific data points as well that it's trained on, that's in gray, and then outliers in red. The confidence intervals span from between 50% confidence to 80% and 95%. We also have other breakdowns in the data. So, for example, when a forecast has been made and then we get the real data, we want to look at the confidence intervals to see how many of those reported data points actually fall within the confidence interval that we're forecasting. So we're expecting 95% of those reported values to be within the 95% confidence interval. So onto the model itself. It is a Bayesian hierarchical model. If you're familiar with Profit's Facebook model, this is quite similar to that. The model is Bayesian, if you're familiar with Bayesian statistics, but if you're not familiar with it, that's also fine. Basically, the way that it works is that the model incorporates prior assumptions we have about the model parameters with historic data that it uses to learn parameter values, such as this sigma variable here, which represents the variability of the ranges of values that you might expect the admissions to take. So it might look at it and say that the values don't range that much, or it could be very high variability from day to day. So the hierarchical part of this model means that information is shared between the time series, helping to compensate for poor quality or missing data. So there may be trusts, for example, that haven't got very good quality data that's reported, in which case it is grouped up with similar trusts, and it can share the information learned there to help produce a higher quality forecast. So these are the main 5 components to the model. We have a general trend, which looks at long-term trend, weekly seasonality, yearly seasonality, bank holidays, and a weather component. So when doing development work on the model, there are some things we need to consider to make sure that the model is valid and actually making things better. So when we're testing model changes, one of the things we're looking at is stability. Will our model fit to a good fit consistently? Because the model technique we're using involves sampling, it's possible for the model not to converge. These charts here show the difference between where the model has converged and when it hasn't. So on the left-hand side here, we can see that those confidence intervals for non-convergence can blow up, and that can mean that the forecasted in red there, we can't really be too confident that that can be a good forecast. Whereas in convergence, we see there's a good model fit to the historical data, can be more confident that the forecast is more accurate. So when I mentioned sampling, the non-convergence risk is because our model learns parameter values by taking samples from the historical data. When it is learning those model parameters, the sampling is run 4 times or in chains. This means that the model tries to estimate the true distribution of the model parameters by taking samples 4 different times. And we expect these to look similar when our model is stable. So for sigma, or looking at the variability, those 4 chains have a very similar distribution, so we're getting good stability there. Whereas when looking at this M chart, those distributions there are quite different. And M is representing the general trend component. So this can greatly affect the stability and cause it to be not as good. So also when looking at the performance, this is about seeing how accurate the model is. Can we use some kind of metric to figure out if the forecast is being accurate or not? Some of you might be familiar with metrics such as like the mean absolute error or MAPE, but when doing this development work, we found that that's not as applicable when we're working with confidence intervals. So for confidence intervals, we wanted to use the weighted interval score, which penalizes on these 3 points. So for example, wide confidence intervals, you could just make a forecast that's like a really large range, but that doesn't really mean anything. We're kind of hedging our bets there. And it also penalizes on true admissions falling outside the confidence intervals and true admissions being far away from the middle of the forecast. So one of the additional features we've been working on recently is adding new sites to the model. So not all trusts and sites are currently being forecasted. That's because it is modeling for those type 1 sites, and trusts, those are ones with an emergency department. This is a sample forecast for a specific site, Bassett Law Hospital, which we've added very recently. And the way that the sites are added is that they are grouped by the mean number of admissions over the last year, according to the hierarchical model. The groups are split such that the range of the metric is equal for each group. And the reason we're doing this is because it's currently the most stable in terms of model performance. So we've also tried grouping, for example, in geographical location, which is a sort of intuitive way of looking at it, but that can cause model instability, and it turns out this is the best metric so far for stable results. So here's just a chart showcasing some of the sites that we've added recently, along with all the other sites that are being forecasted at the moment. So when adding more sites to the model, the grouping information is sent to the model, and then we monitor the performance for a few days before pushing to production. This is where we can do QA and check that the model converges and that the results are stable.
Thank you, Yayo. Okay, so I'm going to talk a bit more about another additional feature that we are working at the moment on adding into the model. So at the moment, we forecast for the number of people who go to an accident and emergency department and are then admitted to hospital. So the number of hospital admissions through accident and emergency departments. But something our users wanted to see was the number of people who attend an emergency department, the number of people who come through the doors. So that's what we've been working on here. So our code had been written in such a way that maybe in the future we might want to forecast for an additional metric. So it was kind of set up so that would be easy to do. And this file here is the file that passes to the model all the parameters that the model needs, all the kind of arguments for the model. And so the idea was that we would just be able to change the metric name here if we were able to pass in the right data. It did turn out there were some kind of dependencies, but this wasn't too difficult to iron out, and actually changing our model to forecast attendances, we were able to get that up and running quite easily. But I suppose then this is a model that's kind of fit to admissions rather than attendances. So to I suppose, develop our model so that it was able to forecast well for attendances. We entered into this kind of development cycle where we would run the model, I would analyse the model outputs, then tweak the model inputs, and then repeat. And particularly what I was looking for when I was analysing the model outputs was, like Yayo talked about, the convergence of the model. A lot of the inputs for the parameters were more suited to admissions. So for example, sigma, that was gives us an idea of the variance of the forecast we should make, how much variability there should be day to day. That's much greater for attendances than it is for admissions. I suppose you're quite limited in terms of how many people you can admit because you only have so many beds, whereas attendances, it's more driven by people's behaviour, whether they go to A&E or not. And so just finding the right inputs for a lot of the parameters took quite a lot of tweaking in that file that we talked about before. But working through this cycle, we were able to find a model that, that fitted attendances well. And so the next step then was really to consider how well was it performing. So we had a model that forecasted for attendances, but was it actually any good? And so this chart is a bit complicated, but really the idea of what we were doing was comparing our model to a much simpler model. So this is quite often done, I suppose, in data science forecasting, but we were doing some naive baselining. So we took a much simpler model and compared it to the performance of our model, really to justify if we could, to see if we could justify the complexity that we were using to forecast attendances. There are lots of different naive models you can use, and sometimes you would just forecast for tomorrow what today's was. What we used was a Bayesian seasonal naive, and so what it does was it was similar to our model in that it had the components that Yayo talked about earlier, but this model just had one component, it just had a weekly seasonality component. What we find is that for some trusts, our model performed an awful lot better than the Bayesian seasonal naive. So that's those big spikes in this chart. That's what they're showing. These do tend to be trusts that don't have great data quality. Our model does perform quite well, particularly when there's recent poor data quality for a trust. It can still make quite good forecasts. Honestly, there were some trusts that did better with the naive method. But what we found was that our model did better for more trusts, and for some trusts, our model did an awful lot better. This chart is essentially comparing their weighted interval scores that Yayo talked about earlier. A positive value means our model's done better, and you can see in the distribution to the right, it's skewed towards the positive side. So I'm just going to move on to talk about a couple of improvements that we made to the model. So these are not things that gave additional functionality to the user, but things that we tried to do in the model to make it forecast more accurately or to make it better in other ways. And so the first thing I'm going to talk about is normalization. This is actually something we did that we couldn't really get to work. That's not to say it could never work, but just we have parked the stream of work at the moment because we couldn't get it to make any model improvements. Again, this is something that's quite common to do in machine learning models. And what normalization involves is taking some of your inputs to your model and putting them onto a standard scale. So in our case, we wanted to put, I'm back to talking about admissions now because that's the work that we were doing when we were doing this work. So we were taking admissions and trying to put them on a standard scale because they're the input to the model. You can see these two trusts here, they're just for example, but this trust in Manchester tends to average at the moment around 300 admissions per day, a bit over. And this one in South Devon is maybe around 70 a day. And so they're quite different magnitudes, I suppose. And like Yaya was talking about the hierarchy in the model, sorry, I'm just going to look at my notes. Or maybe I'll just wing it. The hierarchy in the model at the moment, we group by trust size. So we put all trusts with small numbers of average admissions together, and then larger ones together. This is fine, and we do this because the parameters will be quite different for trusts with different average admissions. While this technique is fine and works, and that's why we do it, we might want to group our trusts on something that's maybe more similar between them. So maybe trusts with similar seasonality patterns or similar geographies in the country. That seems a more intuitive way to group, but we can't do that because of the different sizes of admissions. And that's really why we wanted to normalise, to get away from that so that we could group on different patterns. In terms of the implementation in the model, we were just normalising the admissions before we passed them in to where the model runs. One of the first methods we tried was Z-score normalisation. There are lots of different types of normalisation, but we found this didn't work. So what Z-score normalization does is it means that the admissions now have a normal distribution centered on 0. And what that means is then half your values are negative. And the negative values did not work with our multiplicative modeling approach. Our model would works by, if you think there's going to be an increase in admissions, you would multiply by a largish number, but if you multiply a negative number by a largest number, it gets more negative. And so the negative Z-score normalization didn't work for us. So we were undeterred. We tried some other methods. We tried max-min normalization and dividing by the mean, which are both methods where you don't get negative numbers. We found then that the model didn't like having quite small numbers, so we tried normalizing and then multiplying by 100. But we found none of these really worked. There were problems with convergence, and there were problems with performance. It didn't forecast very well. And I suppose this was just a stream of work where we learned to be resilient. Sometimes work on projects is like finding out that stuff doesn't work. And that was like what happened with the stream of work. We haven't incorporated this into the actual model we use. And then just the last thing to talk about in terms of improvements where we want to make our code open and make it available for people to use, but it's been quite a long project that's been built along quite a lot, and so we really would need to make some code improvements. We want our code to be clear and not be super confused when people look at it, and we want our code to be robust for it not to break easily, or at least if it breaks, for you to know something's going wrong in the background. But this is quite hard because we have over 13,000 lines of code in our model, and we're coding in Python, so it's quite a big job. So one of the ways that you can make your code more robust is by using unit tests. And unit tests are just little small functions that you use to test different parts of the model. They're particularly important when your code's quite nested, so like one function calls another, which our model does. And having these tests allows you to develop your code with peace of mind. The idea is if you do something that breaks a part of the model, the test will fail and you'll find out. The code will tell you. So this is just an example of one of the tests we have. And this test is checking that we're forecasting for admissions. We'd obviously need to change this if we were testing for attendances. And then just the last thing on making the code understandable, we've added doc strings to our code. So these are just pieces of like little strings of text, which tell the user what the function does, and the inputs and the outputs. So that is us pretty much at the end. We're interested in engaging with people about this tool, and particularly at the moment, people in trusts or sites that would find it something that's useful to do. So if you would like to do that, please talk to Yaya or myself, and you can use this link, our QR code, to access the tool as well. Thank you.
Thank you. I'm going to stay sat down because I'm conscious people online haven't been able to hear everything when I'm talking. Also, we've had a lot more questions than unfortunately we have time for. So again, please do approach them if you're here or off online. I think if we can make details available for questions. So we won't be able to get through everything that we've had, but I've tried to group as much as possible. We've had questions around the process that you go through for selecting the priors. You've touched on it a bit, but if you could say a bit more about the process that you go through, how you use kind of weather forecasts, which are really important, also the impact that things like COVID can have, and then finally the shift to same-day emergency care and whether you've been able to account for that. So there's quite a lot in that. And the other one is just touching on, this is obviously available, I think now through the federated data platform, and what's been your experience of that transition onto the FTP. It's quite a lot there, so we'll see how we go for 5 minutes and try and get more in if we have time.
Okay, so the first thing was about the priors and the prior selection. So they are, quite a lot of it is a process of kind of, I did quite a lot of the work of attendances and like thinking about like the impact, like the reality and how you think that's going to affect it. I suppose in that case we had the baseline of admissions. Quite a lot of it is trial and error. So like you try running things for the model, see how it works. We've used a bit of simulation to kind of back propagate some of them. We haven't done a full grid search. The reality is our model is very computationally expensive and it would take a lot of compute to like run a complete grid search. The next thing was about weather and COVID. Sorry, do you want to come back?
Just the kind of things, so have you looked at the impact of weather and COVID? I guess the wider question for this community though is how do you see, if you're using the tool, what you are using, and if you have ideas of what would improve the tool, I guess, how do you feed that in?
Sure. So we do show the different components of the model on the dashboard. For each forecast that's made, we will show the impact of each of the 5 components that Yayo talked about. We include weather, temperature, so that's the only metric we're currently using for admissions, and that was based on basically like exploratory analysis that we did. And we are looking more widely at the moment for admissions because we think there will be there might be other weather indicators that might be more impactful. We get our weather data from the Met Office, and that's how we have access to historical and their forecasts as well. We used to use COVID in the model, and COVID did have a big impact on hospital admissions back in the day. But we have actually it was nearly a year ago, we started to work towards taking that out, and that was based on, we did quite a lot of analysis onto was the impact of COVID still the same. We found that COVID it has a behavioural impact on people, what they do and don't do, particularly at the start of the pandemic. But it also then has the impact of like if there's a lot of COVID about, people get sicker and more people needed to be admitted. So the variables kind of taking those two things into account. But we found because the impact of COVID has changed over time, it was no longer meaningful to have it in.
Just to add on that, from like a user perspective of those components, the way it works is there's an explainability section that we do on the dashboard where you can remove each of these components and see the percentage difference that it makes for each of them.
And if people have ideas of things that you're not in the model, presumably they can get in touch. We're all ears. Yeah.
And also on the dashboard, we do have like a central inbox as well, which the email to is on the dashboard.
Perfect. And this is all on the federated data platform?
Yes, we've just transitioned onto the federated data platform. We didn't, from our side, I didn't work directly on it, our colleague did. I think it wasn't too big of a transition. I think for users it's a slightly different sign-on process and it's supposed to be easier.
It's not something yet that's been developed on there though, it was developed elsewhere.
It was developed on the National Data Platform Foundry. It looks exactly the same there.
Great, thank you. We have got one